What's everybody doing? Right? One Math 158, section 4.2. In this section, we're going to be using matrices to solve systems. In section 4.1, we use the elimination method to solve systems. That is great for a two variable, two equations. But when you have larger systems, more variables, more equations, it's pretty much near impossible to solve them by hand. So what you're going to need is you're going to need the use of matrices, and we're going to be using the TI graphing calculators to help us do that. So definitely have a graphing calculator in front of you. The TI Smart View also works just like a regular calculator. If you haven't downloaded that free version yet, please go out and get that free version. All right. So using matrices to solve systems. So first we're going to start simple. We're going to start with a two variable, two equation setup. All right. So we're starting with x plus y equals 3 and x minus y equals 1. Now this particular one, you're probably looking at it and saying, I could easily solve this with the elimination method. You are correct. You can. But I'm going to teach you how to take this and convert it into a matrix, something called an augmented matrix. Okay. So what we have to do is we have to create a matrix. Our matrix is going to have a column for the x variable, a column for the y variable, and a column for something I like to call the answer column. Okay, it's also going to have two rows. All right, columns go up and down, rows go horizontal. So columns are vertical, like the columns you would see on a building. Rows are horizontal. Okay, so our first equation, we are going to be writing a matrix to represent this equation. What we're going to do is we are going to be looking at the coefficients that we have. So in the x column, the coefficient in front of the x is 1. The coefficient in front of the y is 1. And the answer is 3. So this row represents the x, the y, and the answer of the first system. Our second equation, we have a coefficient on the x as 1, a coefficient on the y as -1, and the answer would be 1. This matrix right here, a 2 by 3 matrix. This would be a 2 by 3 matrix, right? It goes rows by columns. So this 2 by 3 matrix represents this system. We're going to learn later on how to go through and then solve a system with this, but right now I just want to focus on taking the system and creating an augmented matrix based off of that. All right, what I'm talking about is an augmented matrix. So augmented matrix. Okay. So very similarly, just to practice it out, we have 2x minus y equals 3 and -4x plus 2y equals -6. To create an augmented matrix for this, this is also going to be 2 rows and 3 columns. A column for the x, a column for the y, and a column for the answer. So our augmented matrix for this system is going to be 2, -1, 3, -4, 2, -6. That is also a 2 by 3. Next, we're going to get into a little more challenging of a one. Okay, so our next system that we're going to be looking at is -2x over 3 plus y over 2 equals -3, and x over 4 minus y equals 11 over 4. What you can do here is you can just take the coefficients and make an augmented matrix, Or if you want, like we talked about in 4.1, you can eliminate the need for the fractions here. Either way, you're going to get the same answer at the end. I think easiest thing to do is deal with the fractions, because to tell you the truth, we're going to be doing all of this on a graphing calculator, so you don't really have to do any calculations with fractions on your own. So what we're going to do here is we are going to make this. This is also going to be a 2x3 matrix. Our augmented matrix is going to have an X, a Y, and an answer column. And this is going to be representative of equation 1 and equation 2. So the coefficient of negative 2x over 3. Negative 2x over 3, that's the same thing as negative 2/3 times x. So our first entry is going to be negative 2/3. And then y over 2, that's the same thing as 1/2 y. So we're going to write 1/2, and then our answer is negative 3. X over 4, that's going to be the same thing as 1/4 x. Now, negative y, the coefficient is negative 1, and then we have 11/4. Okay. Now, what we're going to do is we are going to be taking this matrix and we are going to be entering it into a graphing calculator. Okay. Let me show you how to do that. Okay, I'm using TI Smart View. I'm using it as a TI-84 Plus. You can use this as well. This is available for free download for you. I believe I sent you the link earlier. If you have any issues with it, contact me and I will definitely send you the link again. Or if you have your own graphing calculator at home, awesome. What we're going to do now is I'm going to teach you how to enter in matrices. Okay. If you look above the x to the negative 1 button, if you can see my cursor, x to the negative 1 is right here. Above that, you'll see the word matrix. So we're going to hit second and then matrix. Hold on, I have to tell my calculator to control it. Apologize for that. Okay, so we're going to hit second and then x to the negative 1. You can see my key presses on the bottom of the screen. You could also see the buttons on the side change to a red color when I press them. What we have here is we now have a list of our matrices. We can't enter in a matrix from this. So what I have to do is I have to scroll right into the edit menu. It doesn't matter what matrix you pick, A, B, C, D, E, F, G. Most of us are just going to use A. So if we scroll over to edit and hit A, we're then able to edit our matrix. First thing you're going to do is you are going to figure out the dimensions of the matrix that you have. This last problem was a 2x3 matrix because we had 2 rows and 3 columns. It always goes rows to columns. So it's a 2x3. If you're not sure, look at what the calculator gives you. If you entered it wrong, it won't look like what you have. All right, so we are going to enter what we have. Now we have fractions. That could be a little bit challenging to enter a fraction into a calculator. You could just use division. So I could use -2 divided by 3 to enter in that, and it would convert it into a decimal. Another thing that I can do is I can hit alpha y equals, and that would bring me into a fraction menu if I hit alpha y equals. So if I choose option number 1, n over d would be numerator over denominator. What I can do, alpha y equals, I'm sorry. Apparently you can't do that. Let's see if I do it this way, -2 alpha y equals 3. There you go. All right, so you have to use that as the fraction bar on an 84. I know on the 84 plus CE that it would enter the box over the box, but I'm using an older version of the Smart View. So I had to figure out something on how to do that. So now we're looking at 1/2. So I could hit 1, then alpha y equals over 2. That enters as 1/2, and then -3. And if I just keep hitting enter, it goes to the next matrix. So 1/4. So 1 alpha y equals 4. And then -1. And then 11/4. So 11 alpha y equals 4. Okay. Now, why I want to use the alpha y equals, why I want to enter them as fractions. When you enter them as fractions and you do something with a matrix, it's going to keep them as fractions for you. You definitely can go ahead and use decimals in this just by doing -2 divided by 3, 1 divided by 2, or you can enter in 0.5. But when you do something with the matrix, you are going to get out decimals. So if you see me getting fractions and you're getting decimals, that's because I input fractions while you're using decimals. I would accept either way, to tell you the truth. Okay, so now I have matrix A input in. Now what I have to do is now I have to use this to do something and find something called reduced row echelon form. Let me go back and teach you a little bit about reduced row echelon form. Okay, so what is reduced row echelon form? Reduced row echelon form, your book tells you how to do it by hand, but I like technology, and if I have a calculator to do it for me, I'm gonna let the calculator do it for me. It's much, much easier for a calculator to do it than to follow along doing the row operations and things like that. That would be very similar to the elimination method, but we're just going to use the calculator to do that. You're always going to have use of a calculator for these type of problems, so do it. All right, what reduced row echelon form is it's reducing the matrix down where you end up with a diagonal series of 1s. Those diagonal series of 1s are then filled in with 0s. All right. So we have our, it's not going to be that many. All right. So this would be a, this would be an example of a reduced row echelon form matrix. This would be a 3x4 reduced row echelon form matrix. But what you're going to see is you're going to see a diagonal series of 1s here. You're going to see a 1, 1, and a 1. And then this last column is going to represent your answers for the corresponding variables. So in some matrix, I haven't shown you those yet, but we're going to have an X, a Y, and a Z variable. And the last row will still represent our answers. So this is a matrix in reduced row echelon form. And what it means is it really means, if you take a look at this first equation, that 1x plus 0y plus 0z equals 2. Then the second row represents 0x plus 1y plus 0z equals 3. And the last last row represents 0x plus 0y plus 1z equals 4. Now, if we don't write the 0y and the 0z's, the 0x, if we don't write the zeros, what do we have? We have 1x equals 2, 1y equals 3, and 1z equals 4. So the reduced row echelon form solves your matrix by telling you what the actual variables would be. Okay, so we're looking for 1s here. So this is 1x equals 2, 1y equals 3, and 1z equals 4. Now let's go back to this problem. Okay, I'm going to show you how to find the reduced row echelon form of this matrix that you already have in your calculator. Okay, so right now your calculator might be in this mode where you've entered your matrix in. What you have to do every time you enter a matrix in is you have to quit back home. So we're going to quit back home by hitting second mode. All right, we're going to be hitting second mode. I'm not clicked into this, so it's not doing it. All right, if I hit second mode, it quits back to the home screen. Okay, make sure your home screen is cleared. If you hit clear, it clears your home screen for you. Next thing we're going to do is we are going to go back into our matrix menu. So you have to quit out of the matrix menu, back to the home screen, and then go back into the matrix menu. So we're going to hit second x to the -1. As you can see underneath your names matrix menu, right? That number 1A, we now have a 2x3 matrix stored in that, right? But what we want to do is we want to find something called reduced row echelon form. So if we arrow right to our math column, we're going to go all the way down. If we keep going all the way down, there's a bunch of stuff here that we can do. We're going to be looking at some of them in other sections. But if we go down to A and B, all right, A is just reduced echelon form or row echelon form. We want to look at B, RREF, reduced row echelon form. So we want to choose B. What it does is it takes that operation and puts it on our home screen. Now we have to tell the calculator what matrix we want to find the reduced row echelon form of. So we then have to go back into our matrix menu. So second matrix and choose matrix A. Okay. So we have reduced row echelon form of matrix A. There's no need to close your parentheses. We're only using matrix A. We can now hit enter. What you can see here from our matrix A is I now have a reduced row echelon form matrix that is 1, 0, 3, and 0, -1, -2. Okay, let's talk about what that means. Okay, so what does this mean? This means this is our X column, our Y column, and our answer column. This one, what does that mean? Oh, geez. That shouldn't be a -1. Hold on. All right, that was my fault. I just copied it wrong out of the calculator. It should be 10301 -2 that you have in your calculator. That was my fault. All right, so when we have this, you can see the diagonal ones, like what we had over here in the example that I showed you. You have the diagonal ones. So this first row, what that means is 1x plus 0y equals 3. So this means that x equals 3. This row is 0x plus 1y equals -2. What that means is that y equals -2. So the answer, the solution to this system is 3, -2. Now, I know that took a long time because we had fractions. I was teaching you a whole bunch of things. Let's run through another one on a quicker way. Okay. Now this system that we have, our next system what we're going to have has 3 variables, an x, a y, and a z, and 3 equations. If you tried to solve this by hand, this is doable to solve by hand, but it's a very complicated process. I'm not going to waste time teaching that. We're going to go right into using an augmented matrix and reduced row echelon form to solve this pretty complicated system. Okay? So what we need to do is we need to come up with an augmented matrix. The augmented matrix has to have a column representing the x's, a column representing the y's, a column representing the z, and a column representing the answer. Okay, so we have 4 columns, and because there's 3 equations, we're going to have 3 rows. So we're going to have a row representing equation 1, a row representing equation 2, and a row representing equation 3. So this is going to become a 3-row by 4-column matrix. This is going to be a 3-row by 4-column matrix. Okay. So we start by taking the coefficients that we have. So equation 1, x has a coefficient of 1, y, -1, z, 5. Our answer is -6. Notice I'm not writing any of the variables here. Do not write variables in an augmented matrix, okay? Equation 2, 3, 3, -1, 10. In equation 3, 1, 3, 2, 5. All right, so that would be our augmented matrix, a 3 by 4 matrix, 3 rows, 4 columns. And now we're going to come up with the reduced row echelon form of this by using our calculator. So, let me share this with you. So what we need to do is we need to first go through and enter in our new matrix. So we go into our matrix menu, just like we did last time. So we're going to hit second, and we're going to hit x to the -1. Second, x to the -1. What we're going to do is we are going to just edit matrix A again. So we go over to the edit menu, and we're going to edit matrix A. We don't need it anymore. So now we have to enter in our new matrix. Now we don't have a 2 by 3 matrix this time because we're dealing with 3 variables and 3 equations. We are now going to have a 3 by 4 matrix. And what you can see is that it doesn't fit it all on one screen, but if you scroll over, it is there. Okay, so we're going to enter in. You can just overwrite what it has, so put your cursor on it, and you're going to hit 1, enter, -1, enter, 5, enter, -6, enter. Then 3, 3, -1, and 10. And then 1, 3, 2, and 5. Okay. So that matrix is in there now. Once we put it in, and it's all there, we have to go through and we have to quit back to our home screen. So we're going to hit second mode to quit back to our home screen. And if you want, I always like to clear and then start again. So now I need to tell it to find the reduced row echelon form of that matrix. So we're going to hit second matrix again. We're going to go over to the math column, and we're going to scroll all the way down to option B, reduced row echelon form, RREF. Okay. Then we're going to tell it what matrix to find the reduced row echelon form of, and that is going to be matrix A. When we hit enter, it gives us our reduced row echelon form matrix. Okay, so our calculator gave us this reduced row echelon form. Let's talk about what that means. I notice that I do have my diagonal sets of 1s here, which is what I'm looking for in reduced row echelon form. And what this means is that 1x would equal 1, so x equals 1. 1y would equal 2, so y equals 2. And then 1z would equal -1, so z would equal -1. Right? What our solution would look like would be 1, 2, -1. Okay, just like in 4.1 when we had a 2-variable 2-system matrix, There are special cases in other ones. When we have, in this case, we have 3 variables, 3 equations. There are special cases, and I want to let you know how to identify those when you do the reduced row echelon form. So let's first create our augmented matrix here. We're going to have 1, 1, 1, 1, 2, negative 1, 1, 0, 4, 1, 3, 3. And now if we go ahead to enter that into our calculator, we are going to enter that into our edit screen for matrix A. This is also a 3 by 4, and we're going to be entering in the matrix that we came up with 1s going all the way across in the first column, and then our second column being second row being 2, negative 1, 1, 0, and our last row being 4, 1, 3, 3. Okay, we quit back to our home screen, and then we want to find, we clear it, and then you want to find second matrix, go to math, scroll all the way down to option B, and then we need to tell it to take the reduced row echelon form of matrix A that we entered in, and we hit enter. Okay, what we see here is, well, first of all, we're not going to see the full matrix on our calculators. If you have an 84, some of the newer calculators will show you the whole thing. I'm particularly using an 84 for those of you that don't have the newest calculator in front of them. Okay, so what we're going to see on the calculator is our reduced row echelon form is 10.67. And then if we scroll over, we can get the rest of it. It's going to be 0. And then if we scroll back by hitting right and left, we have 0, 1.33, and that last one would be 0. And then our last row is 0, 0, 0, 1. Now that last row is what's significant, that 0, 0, 0, 1. What you don't see is you do not see that complete diagonal 1 that we saw in reduced row echelon form. Right? We don't have the 1s going all the way down. We have 1s here, but not all the way down. That last column is representative of 0x, or sorry, that last row is representative of 0x plus 0y plus 0z equals 1, or 0 equals 1. Does 0 equal 1? No. Okay, 0 does not equal 1. I stopped sharing it for you there. All right, so this is what I got out of my calculator. This last row, last row of 0, 0, 0, 1. When we have a last rows with all zeros and then a variable over here, right, that means that we're going to end up with no solutions. Okay, we're going to end up with no solutions when your x, y, z all canceled out in that last row, but not your answer. Okay? That's very similar to what we saw when we were using the elimination method. Elimination, when your x and your y's canceled, but your answer did not, you had no solution as well. Okay, so now we're going to move over to this next one. Next one's a little more challenging. We have some fractions in there. Let's just plug along. Let's do it. So our augmented matrix is going to be 1, 1, 1, 1, 1/4, negative 1/2, 3/4, 0, 1, 7, negative 3, 3. Okay, I'm going to do this in decimals. It's okay. You can do it any way you want. But we're going to go through and we are going to enter that into our calculator again. Okay, I'm on this screen. So now I have to go back into my matrix menu, go over to edit, and I have a 3x4 matrix still, I'm going to keep that in A. There is no way to delete your matrices, so you're just going to rewrite it over again. So we're going to do 1, 1, 1, 1. Then to enter in fractions, you can enter them as decimals. I know last time I used the alpha y equals. This time I'm just going to be okay with decimals. Okay. It's completely up to you what you want to use. And then 0. And then our last row is 1, 7, -3, and 3. So we have it all in like that. And then we're going to quit back out to our home screen, clear it, and then hit second matrix, math, go down to reduce row echelon form, click it, hit second matrix, and then choose matrix A is where we entered this in. Okay, as you can see, I have a pretty messy matrix again. That messy matrix is, let me click into this. That messy matrix is, I can't see it. Great. The messy matrix is 1, 0, 1.67, and 0.67. Our next one, I have this up on the screen, so I'm just going to put it there, 0.33, 0, 0, -0.67, 1, 0, and 0. Okay. So what we have here is similar to when we had the elimination method. We have the bottoms all canceling out. The entire last row is all zeros. All right. If your entire last row is all zeros, what I would say is that it would be infinite solutions. Okay. That would definitely be infinite solutions. So if your entire bottom row cancels out, right, and this doesn't look like reduced row echelon form here. Yes, we have the diagonal ones, but we don't have the other zeros here, right? We would have infinite solutions if it cancels out on the bottom. Now, in a textbook, a lot of you in 4.1 asked me that the back of the book did not say infinite solutions. So I'm going to explain that briefly, what the actual answer would look like in the back of the book here. Personally, I am fine if on a test I give you this and you tell me that this has infinite solutions, that's fine for me. But I just want to explain a little bit about what the book says. Okay, so we have our reduced row echelon form here with all zeros across the bottom. What this really means is that 1x plus 1.67, that would be the z column. So plus 1.67z equals 0.67. And our next row states that 1y minus 0.67z equals 0.33. So if we solve this for x and y, if we get x and y by itself, we would end up getting x equals 0.67 minus 1.67z, and y equals 0.33 plus 0.67z. So we have an x and we have a y, but we don't have a z. Right? As you can tell from here, our z column didn't have that 1 in it. So what they say here is that z is arbitrary. Okay? Z is arbitrary. What that means is that z can be any number. That's where the infinite solutions would be. So if you picked any number z and plugged it in to the x and the y equation, it would work. So the back of your book is going to tell you that your answer to this problem would be 0.67. They would actually probably use 2/3 minus 1.67z for your x, right? That's your x. Your y would be 0.33 plus 0.67z, and your z would be any number. So the solution, so that would be your y, and then your z is just z. The z can be arbitrary. But all these are based off of what you choose z to be. Okay? So I'm just explaining what the back of the book would show you, and if you're reading through the examples, what they're trying to tell you. But the bottom row all cancels out, all zeros, infinite solutions. Okay? Our next problem and our last problem is I'm going to show you what would happen. There is another special case where you have zeros all across the bottom, but there actually are not, there is not infinite solutions to that. Okay, in our last system, all right, we have x plus y equals 1, 13x minus 26y equals negative 11, and 26x minus 13y equals 2. Now, how this is different than the other ones, all right? We've done problems that were 2 variables, 2 equations, 3 variables, 3 equations. You can do 4 variables, 4 equations. But what this one is we have 2 variables, 3 equations. So when you have a different number of equations than you have variables, so this would be 2 variables, just x and y, and 3 equations. Okay, your reduced row echelon form is going to look a little different because, well, we'll explain that, right? So our augmented matrix in this problem, augmented matrix is going to be, it's going to have an x column, a y column, and a z column. Okay, we're also going to have a equation 1 row, an equation 2 row, and an equation 3 row. So this is 1, 1, 1, 13, negative 26, negative 11, and 26, negative 13, and 2. This is a 3 by 3 matrix. It's going to make it a little hard to have our rows, because if we looked at traditional reduced row echelon form here, we would have to have ones going down filled in with all zeros here for it to be those diagonal ones. All right. But this last column, I can't have that cancel out. I'm missing a column. So because I do not have an even number of variables and equations, right? They don't match. Our reduced row echelon form is going to look a little different. So let's look at what that is actually going to look like. So let's share in here. And when I go to enter that in, once again, I have to go back into my matrix menu. I have to go to edit. I'm going to edit matrix A. This has 3 rows, 3 columns. So we're going to enter in ones all across, then 13, negative 26, negative 11, and then 26, negative 13, and 2. All right, so that's entered in. I can check, make sure I entered it in correctly. Hopefully I have. So if I quit back out, clear, and then go into my matrix menu again to math, it's a very repetitive process. A lot of button pressing to get where you want to because you have to quit out each time. Not very user-friendly. So if we hit second matrix and choose that 3 by 3 after reduced row echelon form and I hit enter, okay, what I am going to have is I'm going to have a reduced row echelon form of 10.38, then 1.62. I'm just rounding to 2 decimal places here. and then the bottom is going to be all zeros. Okay. So this appears to be infinite solutions, right? But you can't look at infinite solutions. You have to take into the account that we had an extra equation here. So this bottom row means nothing. But the top row, if we look at it, we end up with 1x plus 0y equals 0.38 and 0x plus 1y equals 0.62. So we have that x isolated to 0.38 and that y isolated to 0.62. That bottom row, because there wasn't a variable to represent that bottom row, right, doesn't matter. So we have to take into account if we have a different number of equations than variables. This is a very special case, okay? So that bottom row doesn't always mean infinite solutions. It means infinite solutions if you have an equal number of variables and equations. So for this problem, we end up with a solution of 0.38 and 0.62. All right, good luck. Make sure you do the suggested homework problems that go along with this section. This is section 4.2.